Okay, this video is for students who'd like to go over quiz 1.1 and look at any questions they got incorrect. There were 3 questions on this quiz. The first one showed you several chemical structures and asked about which of these things about the 3 chemical structures or the 3 chemicals is most likely true. Most of you selected the correct answer, which is C, being that they have different properties as a result of different arrangements of the carbon atoms. The most frequent prompt that, or distractor, I guess a prompt that's incorrect, an answer that's incorrect, was A, that they have the same properties because they have the same number of carbon, hydrogen, and oxygen atoms, which I don't even need to count them out. Even if it's true, oh, it is. I guess it says up here in the chemical formula. The arrangement of things always affects their function. That's a basic idea in biology. So you can just take that to be true for carbohydrates like these. It's going to be true for the shape of proteins will change their function. The shape of DNA or the structure of DNA, how it's put together, the A's, T's, C's, and G's will change its function. So there will be different properties whenever you change the arrangements of the building blocks of that material. Okay? Common mistake, but that's a core idea. If you manipulate the arrangement of the building blocks, you will change the properties of that thing. And that occurs at all levels in biology. Put cells in different places, the organism develops differently. If you change the flow of water in an ecosystem so that now the water is still there, but in a different place, that ecosystem will look different. Even if the water remains, right? Same amount of water, same amount of land, you put the water in a different place, the behavior of the land changes. So this is a fundamental principle in biology that occurs at all levels. This question, which statement helps explain the formation of the hydrogen bonds represented in the figure? Most of you again selected the correct one, that nitrogen has a partial negative charge and the hydrogen has a partial positive charge. You need to think about the hydrogen bonding as being a charge difference and an attraction between a positive and negative end of a molecule. Well, water's always going to have a positive end on the hydrogens, so nitrogen must be slightly negative. Let's see, some of you got it wrong because you described the hydrogen, so you flipped hydrogen and nitrogen in terms of their charges. And some of you said that they both have a positive charge, which does not work. Okay, so we need to think about electronegativity. The electronegativity difference of nitrogen and oxygen are going to pull electrons from their associated hydrogens closer to them, making nitrogen more negative, making oxygen more negative. The result will be that all of these hydrogens will have a slight positive charge on them and will be attracted to any nearby negative charge. Okay. And then the last one was about surface tension. Which of the following best describes how the properties of water at an air-water interface enables an insect to walk on the surface of the water? And so we will see that the water is going to set up with its partial positive and partial negative charges. You should be able to look at water molecules shown in different orientations with the positive and negative charges demonstrated. The correct answer here, again, most of you selected hydrogen bonding between water molecules at the surface provides surface tension. Some of you selected covalent bonds between the water molecules, and it's going to be very important that you do not mix up the concept of a covalent bond with that of a hydrogen bond. A covalent bond is what makes the hydrogen bond possible, but it is not the hydrogen bond. So oxygen and hydrogen share a covalent bond. They share it unequally, which is why oxygen has a little bit more of a negative charge and hydrogen has a bit of a positive charge. But there is a covalent charge or bond. There's another covalent bond over here. It's a shared electron. The electron's not shared equally, but it's shared. Hydrogen bonds, on the other hand, have nothing to do with the sharing of an electron. Their only function is to have an attraction between a positive and a negative end. That was set up by the associated covalent bonds. If you don't understand that, please make sure you're checking in with me, rewatch some videos, draw it out, label the covalent and hydrogen bonds. There will be questions on the test this week, and they will be designed to help me understand whether or not you can tell the difference between different kinds of bonds and what those bonds are doing. Let me know if you have questions.